All right, let's jump right in. Today, we're going to master a shortcut that will totally change how you look at differential equations. The goal here? To solve one of the most common equations out there in just one step. Think of all the time and effort you're about to save.
You know, if you've ever been stuck deep in the weeds with separation of variables, you know what a total grind it can be, right? You're just churning through pages of algebra, and one little mistake, just one tiny slip-up, and boom, the whole problem is wrong. It's so frustrating.
Well, what if I told you there's a way to just bypass all of that work? Seriously. For a huge number of problems, the ones you see all the time in science and engineering, you can literally just jump straight to the answer.
Okay, so the first and honestly the most crucial step is just learning to recognize a specific pattern. I really like thinking of it as a kind of secret code. Once you see it, the lock just clicks open.
And here it is. This is the exact pattern you need to be on the lookout for. Anytime the rate of change of some variable is just a constant times that variable itself, you found the code. That's it.
So what does that actually mean? Well, it's a super fundamental relationship you see all over nature. I mean, think about it, right? The more money you have in an account with compound interest, the faster that money grows. The bigger a population of bacteria gets, the faster it expands. The rate of change is all about how much stuff you already have.
And what's really amazing is that this one little constant, k, controls everything. If k is positive, you get exponential growth. I mean, things just take off like a rocket. But if k is negative, you get exponential decay, where things just kind of fade away. It really is that simple. Okay, so we can spot the pattern, we can tell if it's growth or decay. So now what? Well, now we use the master key, the one single formula that solves every single one of these problems, instantly.
And this is it. This is the master key. The solution is always an exponential function. It's always some constant c times e raised to the kx. That's it. No messy integration, no extra steps to worry about. This is the answer every single time.
So what about that constant c, you might be wondering? Well, it's even simpler than you think. C is just the starting value. You know how most problems give you an initial condition? Something like, at time 0, the value is 10? Yeah, that starting value, what we call y sub 0, that is your c.
So, here it is, the complete shortcut ready to go. You just identify k from the original equation, you grab that initial value, y sub 0, and you just plug them in. That's it. You're done.
All right, theory is one thing, but let's see this shortcut prove itself in action. We're going to start with a classic growth problem and see just how ridiculously fast we can solve it.
Okay, here's our problem. The rate of change is 2 times y, and we're told that at the start, when x is 0, y is 5. Simple enough. Let's start the clock.
Okay, first step, just look at the equation. Right away, we see the pattern. And k is clearly 2. Since it's positive, we know for sure this is going to be growth. Step 2, we just grab our handy shortcut formula.
So let's just plug in the values. Our initial value, y sub 0, is 5. Our k is 2, and bam, the solution is 5 times e to the 2x. That's it. Problem solved in what, a few seconds?
Okay, so that was growth. Pretty easy, right? But does this shortcut work just as well for decay? Oh yeah, absolutely. The process is exactly the same. Let's do another one.
All right, this time our rate of change is negative 0.5 times y, and our starting value is 10. I bet you can already see exactly where this is going.
And once again, we just follow the same simple steps. First, we spot our k, which is negative 0.5. Since it's negative, we know we're dealing with decay. And second, we pull out our trusted shortcut formula.
Time to plug in the numbers. Our starting value, y sub 0, is 10. Our k is negative 0.5, and the final solution is 10 times e to the negative 0.5x. And just like that, we're done. Again.
So, okay, this is a pretty neat math trick. But you might be thinking, why does it really matter? You know, why is this one particular shortcut so important to get down?
Because this equation is, well, it's everywhere. This isn't some obscure pattern you'll see once and forget. No, this describes how capacitors charge up in a circuit, how radioactive stuff decays, how a hot cup of coffee cools down on your desk, even how populations grow. It's a truly fundamental model of the physical world around us.
So for you, whether you're a student or a professional, being able to recognize this pattern is a huge advantage.
On an exam, it saves you so much time and helps you avoid those silly calculation errors. And in the real world, it just lets you model and understand complex systems way, way faster.
So look, if there is just one thing you take away from all this, let it be this. If you see the rate of change equals a constant times the variable, the solution is always that exponential form. Always. Burn that into your memory, because it really is the key to everything we've just talked about.
So now you have the master key. It's a tool that lets you completely bypass all that tedious algebra and get straight to the solution. And that means you can focus on what the answer actually means. So the only question left is, now that you have this key, what problems are you going to unlock?